Okay, so this is going to be section 2.3 of my PreAlgebra series, and here we're going to talk about combining rules to solve equations. So we're going to use this addition and multiplication property, and this is just going to be a rehash of 2.1 and 2.2, so we'll practice some more equations. We'll see some of these equations, for example, that involve some more parentheses, and I believe we have seen a couple of those. One new idea that we're going to talk about is going to be recognizing identities. So you can see, for example, I've got an equation that looks exactly the same, and we'll talk about those in a little bit more detail. And then not every type of linear equation has a solution. So we'll talk about recognizing equations with no solutions. So this is my little recipe for solving linear equations, and this is kind of my general guideline, and it's nice because once you do a few linear equations, you'll see that really they do kind of, you really can just kind of follow a recipe, much like a cookbook, I think, to solve them. So this is my general procedure, and you'll see there is a little bit of flexibility. So the first thing that I like to do is I like to get rid of all of those parentheses. And then my next goal is I just start combining like terms, usually on each side of the equation. And what I'll do is, next, step 3, I'll put all terms involving a variable on one side of the equation and all the constants on the other side. So I'm kind of separating the variables and the constants. And then, as we saw in 2.2, we can divide by the coefficient of the term involving the variable, and we'll just simplify. So, okay, let's talk about this. Okay, so here we've got negative 4x equals 5. Well, a lot of those steps are already sort of done, right? There's no parentheses, everything is combined. So in this case, all we want to do is our goal is just to get down to x equals, right, some number. This is our goal. And if we can do that, we're done. Well, on the left side right now of my equation, I've got negative 4x equals 5. Right, we've got this negative 4, and we don't want that, so since we're multiplying by negative 4, well, to undo multiplication, we can do division, so I'll simply divide both sides by negative 4, and on that left side, negative 4 divided by negative 4, that's just going to leave us with positive 1x, and on the right side, there's really nothing to simplify. We've got a positive over a negative, so that's going to be a negative. And typically you'll see that negative number written out front. You could leave it in the denominator or put it in the numerator, it doesn't matter. And unless people want a decimal, I would leave this as a fraction, just as negative 5/4, and that would be our solution. Okay, so part B here, we have 4x plus 5x equals 9 minus the quantity, or 9 minus negative 13, I should just say. So in this case, I think we can start off by simply combining our like terms on each side. So on the left side, well, 4x plus 5x, those are like terms. I can just add and get 9x. And on the right, 9 minus negative 13. Well, those two negatives make a positive. That's the same thing as 9 plus 13, or 22. And now, much like our first example, to get rid of that 9, we can just divide both sides by 9. That would give us x equals 22 divided by 9. Again, that doesn't reduce, so that would be my solution. C, again, very similar. We've got x divided by 8 equals 10. So now we're dividing by this number instead of multiplying. Well, if I want to get the x by itself, since I'm dividing by 8, I can simply multiply both sides of my equation by 8. So if I do that, on the left side, the 8s will simply, 8 divided by 8 is just going to leave me with 1x. And on the right, 10 times 8 is 80. Okay, so let's go through these a little bit faster here. On D now, I've got x's and constants on each side of my equation, so I'm going to start by combining those. And I'm going to do two steps at once. So maybe I'll subtract 5x from both sides. Again, I like to subtract the smaller number from the larger number, and I'm comparing the 10 to the 5. Well, 10 is larger than 5, so I'm going to move this that 5x. I'm going to get rid of the 5x on the left, or excuse me, on the right side, and move it by subtracting it from both sides here. Okay, so 10x minus 5x, and we could do another thing as well. Well, let's do it one step at a time. So 10x minus 5x, that's going to leave me simply with 5x on the left. I still have my plus 4 on hanging out on the left side. Now the 5x minus 5x, that just cancels, and that's what we wanted to do. We still got our positive 18. So in effect, what has happened? We've still got a variable and a constant on the left side, but notice on the right side, now before we had a variable and a constant, now we've only got a constant. So that's good. We're kind of reducing things. And I'll do the same thing. I'm just going to subtract 4 from both sides now to get rid of that constant. That's going to leave me with 5x equals, well, let's see, 18 minus 4 is going to leave me with 14. And so let me pull this up here. And just like our other examples, the last thing we would have to do now is simply divide both sides by 5. So if we divide both sides by 5, we would simply be left with x equals 14 over 5. So I'm not going to write out that step of dividing both sides by 5, and typically you won't see people write that step out. We just kind of, we'll jump from here to here. Okay, so that would be our solution. Let's keep going. Part E and part F, and okay, part G, 3 more. And then we'll start talking about our identities and no solutions. So the only thing that's happening here is we have parentheses. So we've got to distribute. So 5 times x, 5 times negative 3. So I would have 5 times x, or 5x. 5 times negative 3 is negative 15. And on the right, I still have my 4x hanging out. Now, you could imagine that this is a negative 1 hanging out in front of the parentheses. So I'm going to distribute that. So we need to change the sign when we on the terms inside the parentheses when we remove the parentheses. So that would give me negative x, and it looks like a minus 7. Now, there's nothing to combine on the left side. I don't have any like terms, so I'm just going to leave those alone. But on the right, I can combine 4x minus x. That's going to leave me with 3x minus 7. So I'm going to subtract 3x from both sides. If I subtract 3x from both sides, that's going to leave me with 2x on the left and just the negative 7 on the right. Now, next, I'm going to add 15 to both sides. So that's 2x. So let's see, negative 7 plus 15. I think that's going to give me positive 8 if I add 15 to both sides. And now I can divide both sides by 2, and that will give me my solution of x equals 4. Okay, so F, we've got yet more parentheses. So again, we're just going to, in that first set of parentheses, we'll distribute that 10. On the second set, we'll distribute by the positive 3. And then on the left set, notice I've kind of written it a little strange. I've got 2x plus 1 plus x. You could go ahead and distribute immediately if you want to, or you could combine. Now, I would probably go ahead and combine those first just to speed things up. So I'm going to go ahead and do a simplification here. Notice we have 2x plus 1 plus x. Well, if I combine those like terms, 2x plus x is going to leave me with 3x, and then I would still have the plus 1. Okay, so let's do all that distributing now. So 10 times x is 10x. Now, 10 times negative 1/2, so a positive and a negative is a negative. I've got 10 times 1/2. Well, 10 times 1/2 is the same thing as 10 divided by 2. And 10 divided by 2 is simply going to leave us with 5. So we would have 10x minus 5. Now let's distribute our positive 3 next. So that's going to give us 3 times 2x, which is 6x. 3 times negative 1 is going to be negative 3. And let's do our distributing on the right. 7 times 3x is going to be 21x. 7 times positive 1 is going to be positive 7. And again, I'll combine like terms on the left. So I've got 10x and a 6x. That's going to leave me with 16x. Negative 5 minus 3. That looks like negative 8. Nothing to do on the right side. And what I'm going to do is I'm going to subtract 16x from both sides. So if I subtract 16x from both sides, it would be gone on the left. I would be left with negative 8. 21x minus 16x is going to leave me with 5x. So again, I'm not writing all these steps out now. And then I would subtract 7 from both sides. So negative 8 minus 7, that's negative 15, equals 5x. We can divide both sides by 5. Negative 5 divided by, negative 15 divided by 5 will leave us with our solution of negative 3. Okay, last but not least, now we've just got some fractions. 1/3 x minus 1/2 equals 2/5 x plus 8. There's a couple different ways you could do this that are certainly all equivalent. We could go ahead and start combining like terms. You know, I could subtract, so if I want to combine my x's, I could either subtract 1/3 x from both sides or 2/5 x from both sides and do like I was doing before. Now, another thing I could do is I could try to get rid of those fractions, and I think that's a good idea a lot of times. So again, what I'm saying here is there's more than one way to do these. So what I'm going to do is I'm going to think, I want to try to get rid of these fractions. So what I'm going to do is I want to multiply by some number on the left that's going to get rid of my fractions. Now, the thing is, whatever I multiply on the left by, I would have to multiply on the right by as well. Now, what we're going to do is we're going to look at the denominators. I see a 3, a 2, a 5, and we could write this as 8 over 1. So we see a 2, a 3, a 5, and a 1. And what we're trying to think is, what's the smallest number I can multiply both sides by that are divisible by 3, 2, and 5? Well, I think the number we could use is, what if we multiply both sides by 30? And technically, you don't have to use the smallest number, but it just makes the arithmetic easier. Okay, so if we do this, we're clearing the denominators, what we're doing. So this one's a little more tricky, so it may take you a little more. If you're not used to these, you may have to stop and slow down. But again, we're getting rid of fractions. That's what we're trying to do here. Okay, so I still have to distribute. So this is going to give me, let's write it out. This is going to give me 30 over 3x when I multiply, minus, okay, I would take 30 times 1, and you could think again about this as being a fraction, and I would have just 2 in the denominator. So, okay, so if I distribute, I would have 30 times 2, which is 60, over 5 times x, and then I would have 30 times positive 8, which is 240. Now let's simplify. So this is the magic, right? Because I've still got fractions right now. But 30 over 3, that's just 10x. 30 divided by 2, that is 15. Now 60 divided by 5, that's 12. We still have our x. Plus 240. And now we're pretty close, I think. So what I'm going to do is I'm going to subtract 12x from both sides. So if I subtract 12x from both sides, 10x minus 12x is going to leave me with a negative 2x. And then what I'm going to do is I'm going to add 15 to both sides. So 240, which is on the right, if I add that 15 to it, I'm going to get 255. And again, I've already dealt with the x's, I've moved the 15, I've combined that with my 240, so that looks good. And now, okay, well, I've got this negative 2 out front. We can just divide both sides by negative 2. So that's 255 over negative 2. But if you want, we can pull that negative out front, and there's our solution. Okay, so we got rid of fractions. You definitely don't have to do that. We could have just started moving terms around at the beginning and getting common denominators. So for example, 1/3 x minus 1/2. So here's our original equation, right? Equals 2 over 5x. What do we have? Plus 8. Now, if I wanted to, and I'm not going to do this one all the way out, I could have subtracted the 2/5 x from both sides. And I could have added 1/2 to both sides. So this is certainly a correct step. And now, again, you could get rid of fractions like we did by multiplying both sides, or you could simply get common denominators on each side, start combining them, and eventually after you do that, you're going to end up with just something like we had at the very beginning. You're going to end up with something multiplied by x equals some number. After getting all of those terms combined, you'll end up with something that looks like that. I'm not saying it's negative 4x equals 5, but then we can just use the same techniques as before. Okay, so what's the moral of this long-winded story? Many ways to do these, so keep that in mind. Okay, there's different orders that you can do these steps. That's totally okay. Okay, so now we want to talk about identities and equations with no solutions. So the first thing that we're going to talk about is what's known as an identity. And again, keep in mind what we're trying to do when we're solving these linear equations. What are we doing? So, for example, when we looked at this linear equation, negative 4x equals 5, we're thinking, what number can I replace the x with so that when I multiply it by negative 4, I get 5 out as a solution? Well, there's only one number that does that, and that one number is negative 5 over 4. That's the solution. Well, what solutions would exist for this equation? You know, what are the solutions to this equation? 3x minus 7 equals 3x minus 7. Well, I think there's a lot of numbers, right? Because no matter what I plug in on the left side, I'm going to plug it in on the right. We're going to get the exact same number, right? It doesn't, you know, so suppose we plugged in, right? I think it's pretty easy to see. Plug in, I'm just picking a number at random, x equals 10. Right? On the left, you would get 3 times 10, which is 30, minus 7. You're going to get 23. You would get 23 on the right as well because it's the exact same thing. So x equals 10 would work. But any number you could plug in. You could plug in x equals 1. That would work. You could plug in x equals negative 4.8. That would work. So all this number had all values of x satisfy this equation. And when that happens, what we do is we call this an equation an identity. So we would say 3x minus 7 equals 3x minus 7 is an identity. Now, you'll see here in a second, we may have some equations that are identities that may not look like it. I mean, this one's pretty obvious, right? Because you can look at it and be like, well, I got the exact same thing on the left as I've got on the right. It's clearly the same. Suppose, though, maybe you were playing on your cell phone or staring at your handsome teacher, Patrick JMT, and weren't really thinking, what would happen if you just went through this using these techniques from before? Well, notice what would happen. If I subtract 3x from both sides, I'm going to get 0x on the left side, or I could simply just write that as 0. 0x is the same as 0. And notice if I add 7 to both sides, I would get 0 equals 0. So when you get these kind of statements, when you get some number equals itself, and it doesn't have to be, eventually it will come out to 0 equals 0. But if you end up with a statement like you've done some work and you end up with something like 8 equals 8, or I don't know, negative square root of 2 equals negative square root of 2 when you're solving these equations, when you get something is equal to the exact same thing, that means, again, you have an identity. Okay. Well, now that begs the question. Okay, so an identity, it means that all numbers are solutions. It means you have the exact same thing. Now, is it possible to get no solutions? How do we recognize those situations? Well, we'll talk about it. So let's determine if these are identities or no solutions. So the part A, if I distribute on the left, well, I would have 3x minus 6. Well, that equals 3x minus 6. Clearly, this is an identity. Maybe we didn't recognize it. Let's subtract 3x from both sides. That would just leave me with negative 6 equals negative 6, which, again, this is what I was saying like up here. Okay, so already, again, I can recognize that's an identity. Maybe I add 6 to both sides. Notice eventually you will get down to the statement that 0 equals 0. That tells us, again, that this is an identity. Now, let's look at part B. 4x minus 3x equals x plus 8. Now, notice on the left we can simplify. 4x minus 3x is just x. Now, if we leave the right side alone, we still have x plus 8. Now, what number can you start with? Let's think about what this equation even says. It says, what number can you start with? And then take that same number and add 8 to it, and have those numbers be equal. Well, intuitively, none, right? Because if you add 8 to a number, you're getting something totally different. They will never be equal. But again, just algebraically going through the motions, if we subtract x from both sides, well, if I subtract x from the left, that's going to leave me with 0. If I subtract x from the right, that's just going to leave me with positive 8. And notice now we're getting one of these statements. It's a 0 equals 8, which is, well, that ain't right. Right? That ain't right. There's something wrong here. This is not correct. So what is it telling us? It's just telling us that our equation has no solutions. So moral of the story, if you get some equation that clearly two things are not equal, that's no solutions. If you've got an equation where two things are exactly the same, two numbers, or, again, like we started off with, two expressions that are clearly equal, then you're going to have an identity. Okay, let's see here. Let's just go through a couple more. So part C, let's distribute. 3 times 2x is 6x. 3 times negative 7 is going to be negative 21. We'll leave the right side alone. Well, clearly these are not going to be the same because I have 6x on both sides, but then negative 21 and positive 3. Well, if I subtract 6x from both sides, again, I would be left with something like negative 21 equals 3. And clearly this is nonsense. So this tells us that we have simply no solution. All right, last but not least, let's try one more, because I'm looking at this immediately, and maybe I don't recognize whether this is going to be an identity or no solutions, or maybe it just simply has a unique solution here that we have to find. So let's see if we can't come up with a solution for this one real quick. So we'll do the same thing. We'll just distribute. So negative 4 times x is negative 4x. Negative 4 times positive 2 is negative 8. Now notice the negative 4 is only being distributed to those terms in the parentheses. So this negative 11, that one is just hanging out. It's just watching. Okay. Now on the right side again, we'll just take that 2 and distribute it to those two terms in the parentheses. So 2 times negative 2x is negative 4x. 2 times negative 3 is negative 6. And I still have my minus 13. So let's see here. What have we got? Okay, I think we were already getting into some issues. Or no, I think I see it. So if I combine like terms on the left, we have negative 4x. Negative 8 minus 11 is negative 19. Notice we've got on the right side negative 4x. Minus 6 minus 13, that is also negative 19. And at this point, I simply recognize that, hey, those expressions on each side of the equation, those are the same. Yeehaw. So that tells me that we have an identity. Okay, so this is what I meant, right? If you get something, what do we start with? We started with this. 3x minus 7 equals 3x minus 7. Those are clearly equal. Well, okay, so I kind of wrote this one in a slightly funny way, so maybe it wasn't as apparent that they were identities. But after doing that arithmetic, we can conclude that. And of course, you could have gone through the steps, negative 4x minus 19 equals negative 4x minus 19. You could have done that arithmetic and eventually arrived at something like 0 equals 0, and we would know that it's an identity. Okay, so that's it for this section. Just some a couple new identities, no solutions to equations, and then just a rehash of 2.1, 2.2. You will be, again, solving linear equations all the time. Don't be thrown off by if you have fractions or decimals or anything like that. You're still doing the exact same thing, but I certainly agree with you out there. It can make the arithmetic a little tricky, but again, the process is the same. So do keep that in mind and use that as a guiding light as you go through these. All right, I hope this helps. I hope this makes some sense, and good luck to you.